Hi, my name is Jenna. I'm currently a sophomore majoring in environmental science, and for my internship, I was working under Dr. Liz Callies from the Nature Conservancy. And just for some background on the Nature Conservancy has been working with the solar industry over the past 4 years to develop better siting tools and on-site management practices that ensure that development for clean energy does not compromise natural communities and wildlife. They've worked at solar facilities to implement conservation practices, including pollinator vegetation, wetlands, and wildlife permeable fencing, and have also conducted monitoring at solar facilities to determine pollinator abundance and wildlife presence through camera traps and calculating pollinator counts. And for what I did as an intern at TNC, so here's a list of my goals and responsibilities. So as an intern at TNC, my main goals were to develop drone imagery in ArcGIS Pro through classifying everything that is at the solar facility, such as grass, flowers, buildings, solar panels, water, trees, and also calculating the EBI bloom. After creating the imagery, I was to continue the report about my findings and connect it to pollination, and if adding seed mixes to certain solar facilities actually did anything. I also sorted through an assortment of photos from different camera traps that were set up at the different solar facilities to test the different fencing that was specifically made for wildlife to get through, and then of course meeting with my mentor and keeping her updated on my work. Okay, and for the purpose of my work was to process the drone imagery in ArcGIS Pro and to classify the amount of landscape on the solar facility that can be used for pollination and wildlife. And then the purpose for sorting through the camera traps was to add to the data about different species of animals in the camera traps along with their location to aid towards the research of permeable fencing. And I did, as an intern, I did a total of 4 solar facility sites to track and calculate the bloom of each site to see how much can be used for pollination and sustaining wildlife in general. So I did Moore, Four Oaks, Willow Springs, and Phipps Bend. Okay, the process of classifying the landscape is to classify the drone imagery. That's step 1. For step 2 is to calculate the raster for the raw drone imagery, and then step 3 is to calculate the EBI through the raster data. So for the process, firstly, I classified the drone imagery to see what was solar panels, grass, wildlife, anthropogenic, and dirt. And I did this by importing the raw drone image into ArcGIS Pro, running it through a training sample that was given to me, and then reclassify different parts to make it more accurate. Next was calculating the raster for the raw drone imagery, and which was basically the raster is the matrix of the pixels organized into rows and columns, and then after doing that, then classifying those pixels based on the range of how much red, blue, and green they have in each pixel, and separating the pixels to be either bloom or non-bloom, and by using a certain code, and then running it, and then this is the imagery that you would get. And then for the third step, which was calculating the EBI through the raster data, this was the last step. So I just reclassified the data by inserting another range of if it's bloom or non-bloom. So like wildflowers and anything of that nature. And then everything else is black. So, and then here is a graph of the raw colors for the Four Oaks site along with the number of pixels at each site. So on the x-axis, we have the wavelength, which is basically like what colors, and then the data value. And then the pixel count is in the table to the side. Next, I have a photo of the finished EBI bloom classification. So the white is the pixels of bloom and the black is the pixels of non-bloom. And after putting it into ArcGIS Pro, the bloom coverage was 0.96% of the total solar facility that I covered. And then next, my deliverables as an intern for TNC was to process the drone imagery through ArcGIS Pro and then upload it, and then update the report on land classification results and processing camera trap imagery. So for the camera traps, I basically just sifted through a lot of pictures that the camera traps took, and then saw if there was like wildlife in them, if they were inside or outside the fencing, and what location they were at. So in the first picture is a chirping sparrow at the Phipps Bend site, and then oops. And then the second picture is a white-tailed deer at the Phipps Bend site. And you can see in the back the permeable, semi-permeable fencing in the back, that the holes are bigger so that wildlife can get through easier. Okay. And then what I've gained as an intern for TNC is ArcGIS skills, because I basically had none. I never entered the software in my life. And then so I understood the mapping more and the classifying the imagery more. And then I gained some report writing skills because I continued writing the drone imagery report and the land classification report, and updated the methods and analyzed the data of the imagery. Next, I gained some networking skills, getting to know some of the staff at TNC and working a little with past interns. Next, I just want to say thank you to my mentor, Dr. Liz Callies. Thank you so much for giving me this opportunity to be a part of this project. Thank you for your time, patience, and commitment to my learning. Thank you for being such an amazing mentor and helping me reach my goals and being supportive, even if I have my little ups and downs learning all this stuff. And any questions?